Determine if the series converges or diverges. We have 1/2 plus 1/5 plus 1/8, and so on. We first need to write a formula for the infinite series, and then we'll determine what test to use to determine convergence or divergence. Because all the numerators are 1, let's focus on the denominators of 2, 5, 8, 11, 14, and so on. Notice we have a pattern of addition. 2 plus 3 equals 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14, and so on. This indicates the denominator is an arithmetic sequence. To find a formula, because we have an arithmetic sequence, we have a sub n equals a sub 1 plus the quantity n minus 1 times d, the common difference, where in our case, a sub 1 is 2, and the common difference d is 3, which gives us a sub n equals 2 plus the quantity n minus 1 times 3. Simplifying, we have a sub n equals 2 plus 3n minus 3, which simplifies to 3n minus 1. Remember, this is the formula for the denominator, not the entire sequence. We can write the infinite series as the sum from n equals 1 to infinity of 1 divided by the quantity 3n minus 1. Notice when n equals 1, we do get 1/2. When n is 2, we get 1/5, and so on. Because we can easily integrate 1 divided by the quantity 3n minus 1, the integral test is a good choice to determine convergence. Recall, for the integral test, we have a sub n equals f of n. From this, we form the function f of x, where f of x must be continuous, positive, and decreasing on the interval from k to infinity. Once we have the function in the interval, we evaluate the improper integral of f of x from k to infinity. If the integral converges, so does the series. If the integral diverges, so does the series. In our case, notice f of x will be 1 divided by the quantity 3x minus 1. Even though the index starts at n equals 1, we should analyze the graph to verify the interval for which f of x is continuous, positive, and decreasing. I've already set this up. On the right, we have the graph of the terms in the series. And now if we graph the function f of x equals 1 divided by the quantity 3x minus 1, notice the function is positive, continuous, and decreasing over the interval from 1 to infinity, which will be the interval of integration. And now to apply the integral test, we evaluate the integral from 1 to infinity of 1 divided by the quantity 3x minus 1 dx. Notice this requires substitution, where we have u equals the denominator of 3x minus 1, indicating du equals 3 dx. We don't have 3 dx, we have just dx, so let's divide both sides by 3. We have 1/3 du equals dx. Now let's write the integral with respect to u. We will leave the limits off for now because 1 and infinity are x values, not u values. We know the denominator is u, and 1 dx, or dx equals 1/3 du, which gives us 1/3 times 1 divided by u du. And then when x equals 1, notice u is 3 times 1 minus 1, which is 2. And as x approaches infinity, so does u. Because we have an improper integral, let's write this as the limit as b approaches infinity of the integral from 2 to b of 1/3 times 1 divided by u du. The antiderivative is 1/3 natural log absolute value of u. We can leave off the absolute value because u is always positive. We have the limit Now we determine big F of b minus big F of 2, which gives us the limit as b approaches infinity of 1/3 natural log b minus 1/3 natural log 2. As b approaches infinity, 1/3 natural log b increases without bound, very slowly, but it does, and approaches positive infinity, which indicates the limit approaches infinity. which does not exist, which indicates the improper integral diverges, and so does the series. So the series diverges by the integral test. I hope you found this helpful.